During the introduction has been presented for robots. So robots are humanoids, so they are cute, and they are designed to interact with human beings. It means we took a lot of attention in their appearance. They look nice, they look cute. As soon as you see them, you want to interact with them. There is a Pepper downstairs, so we have if you never experimented the interface interaction with one of our robots, it's a good opportunity for you to go. So now, originally, our first robot created in 2000, the company was created in 2005, and in 2007, we presented the first prototype of Now, the little one that you can see here on the left. And today, it's mainly dedicated. Originally, we wanted to have it as a companion for the family, but it appears that it's quite difficult to have a robot today. Having the robot, it's easy, but having the application dedicated to the family, and that could be a real companion, it's quite difficult. So the first market we had with this robot was research and education. And then some years later, we were looking for investors to have a more and more application on our robots and to make a large diffusion of it. And then we met SoftBank at that time. And SoftBank told us, OK, we've been looking all over the world, the best company to manufacture a robot for us. SoftBank is a Japanese company. So the Japanese company went in France to visit us and say, we think you are the best to develop Pepper, the robot we want to have in our shops to welcome people. And then we developed for them Pepper. And in parallel, we have been working on a research project that is Romeo. Romeo is here. You can see it. It's a 1 meter and 40 centimeter high robot dedicated to, originally, assistance to elderly people. So we have been doing a lot of research on it. And today, our main products are Now and Pepper. Romeo is just a prototype, but there is one of them in TU Vienne, not so far from here. So as I said, the market we are looking for are education, mainly. So we today already are dealing with the market of education. So Now and Pepper can be used to either to teach programming, to teach robotics, but also in very small, small classroom with children. You can teach many other domains with it. You can use the Now to teach multiplication table, poetry, colors, to recognize animals. So and these robots are a very good way to make the connection between the teacher and the child. Of course, the robot won't replace the teacher, but it's a tool, a very good tool for the teacher to drag the attention of the kids. B2B, what we call B2B is our main market today, welcoming people in shops, giving information, entertain them. So Pepper is a perfect robot for that, because Now is very small. So if you come into a shop and you can walk on Now, you won't see it, or in France, it can be stolen. So Pepper, a taller robot, is much better for this kind of application. But the next steps, the next market we are looking at is senior care. We have demonstrated with Romeo that it is possible for this robot, humanoid robot, to assist people, elderly people, when they are lonely, when they are losing their autonomy, in very simple tasks at the beginning, and then maybe later in much more complicated tasks, like helping to prepare the food and so on. But already today, Pepper can assist someone for cognitive tasks, reminding medicine, taking care of, or is a person fallen down? Maybe I should call the assistants, or the robot can be a cognitive support. These people, are very lonely, and they don't talk to anyone. And maybe the robot could be a way for them to keep on discussing with someone. OK, robot is not someone, but it's better than nothing. And robot can maintain the contact between the person and his family. And the robot say, OK, we haven't been talking. You didn't talk to anyone since one month, maybe, or 1 week. We can call your family or your doctor to give news or to get news. And last but not least, of course, what we are dreaming of is to have a robot as a companion for the family. This is very difficult. This is very difficult because in family, you already have your tablets, you have your Alexa, you have your you are healthy, so you can do plenty of things by yourself, and asking the robot to wash the dishes, to push the vacuum cleaner, it's very difficult, and today we are not able, technologically, we are not able to do this. So we keep that in mind, and also what we do is to try to explain to people what you can really expect from a robot now, in the next 5 years, then in the next 20 years. And with SoftBank behind us, we know that we can work for the next 20 years to someday come up to this companion for family with a robot that will make everything you can dream of. All this work is done in collaboration with academic labs, with industrial partners, and within, for instance, European project. Here you can see a European project in which we're collaborating with many teams. So that's it for the overview of the company. Now let's go into a robotics question. So as you know, the point of robotics is to implement this loop between, okay, I see something, I take a decision, and then I act. So this loop is very specific to what we call control or robotics, because the robot moves, the robot acts, so he has to act in a clever way based on a decision and based on what the sensor shows. Originally, artificial intelligence, when I started that in the 80s, was mainly focused on decision. You know, it was this rule-based system. If this, do that. If someone is crying, then bring a tissue, and so on. So it was mainly there, a rule-based system. Then artificial intelligence focused on perception. My master degree in artificial intelligence was about shape recognition. It was artificial intelligence and shape recognition. At that time, recognizing squares, circles was artificial intelligence. It was the very beginning of intelligence, but it was. But today, of course, what is interesting is to use this artificial intelligence in action. And I will try to show you some example of what kind of actions a robot can do, and then together we will think about when is really artificial intelligence needed. On some example I will show you, maybe you'll tell me, but it's not artificial intelligence. It really depends what you put behind this word. If for you artificial intelligence means deep learning, of course, I will show you some deep learning stuff, but today we have plenty of things to do without deep learning, but what we used to call, when I was young, artificial intelligence. Face recognition, speech understanding, and so on. So this is the kind of artificial intelligence we need in our robot. I'm often asked, but okay, your robots are wonderful, but is there artificial intelligence in it? And in the question, behind the question often there is it completely autonomous? Can it take over the humanity? And can it decide by itself what it does? And my answer is, yes, there is artificial intelligence in my robot, but not this intelligent artificial intelligence, but a good one, a simple one, that really allows me to make useful tasks for you. So classical task, when you have a robot, is bring me a bottle of beer from the fridge. We are not yet now, but that, of course, the most important task we have in mind. But today, it's just bring me this box, this blue box on the table. So everything is simple. The box is big, it's blue, as you can see, not a blue table. And then, for the robot, it's quite simple to localize the shape, a blue shape, with the two ends vaguely to close the ends where the box is more or less supposed to be, and then take it and bring it to the one who asked for the box. That's the very beginning of grasping. Grasping is something that you do every day, all the time, very easily. But it's like walking. When you think a little bit about that, it's very difficult to know. It's because you know the way you should grasp the object, you know more or less you can imagine the weight of the object, so you know how strong you should grasp the object and so on. So when you try to implement this in the robot, you see how complex it is. Here, in the next video, you'll see the way it has been done in a little bit more sophisticated way. Here, the robot grasp is only one hand. But because our robot is not an industrial robot, it's a companion robot. It's not very expensive. It's expensive, of course. When you have to buy it, you will find it expensive. But from a robotic standard, it's not that expensive. And it makes that the motion of the robot are not so accurate. And just grasping an object, knowing the position of the object, is not often also easy. So here you've seen during the beginning of the video, the robot was looking for the object. So he localized the object based on the edge of the object. But the robot was also localizing its own hand to be sure that the accuracy of the position in open loop of the hand was accurate enough for the hand to grasp the object. So then the robot has to localize in the same way, in the same time, the hand and the object. And if you think about that, try. I won't do it because my computer is just there. But if I close my eyes, I look where is the glass, and then I close my eyes and I try to grasp the glass, okay, I'm in trouble. I could be in trouble. So that's why permanently what I do is I have the closed loop between what I see and what I do, and I check that my hand is around the glass before grasping it. This has to be implemented. And if localizing a box is quite easy, localizing a hand is not that easy. That's the reason why maybe you mentioned at the very beginning of the experimentation, there are some dots on the hand that makes the hand much easier to localize with the eyes. And of course, with best perception, like deep learning stuff, we can try to localize the hand without the beacon, the markers on the hand. Grasping is a very important function for the robot. Today, this is still a research development for us. Of course, in labs, you will see beautiful hand doing beautiful things, but if you want to make it with a $50 hand, that's not that easy. So we're working on developing a new hand and new algorithm for grasping. Another important thing, why do I talk about that? It's because we have to make the difference between Alexa and a robot. What is the difference between Alexa and a robot? Alexa just talk, and then all robots are speaking, talking. We're implementing chat, and I will show you what we do. But of course, the difference between a robot and this kind of device is the grasping and the motion. And motion, I don't know how familiar we are with the motion in robotics. Plenty of work has been done with what is called SLAM, simultaneous localization and mapping. Here, the robot will use the sensors that are in the base, giving very simple information. Originally, this sensor was only meant to avoid collision. So either an obstacle in front or not, and then I stop. In fact, we have been able to use this sensor, very simple sensor, to build a map of the environment. So the robot explores the environment, and only based on this very simple data, it will build a map of the environment. And then it will detect if there is somewhere it never went, and then it will keep on exploring to find all the walls. Actually, it's looking for all the walls to have a closed environment. When he has a closed environment, it understands that he has explored all the space. And then, once this exploration is finished, the robot has a map. Okay, the map is ugly. That's not the kind of map you expect from an architect. But for the robot, it's enough to navigate. And then the next step we need to have, if we want to discuss with a robot, is to match the map and the way we name the place. So we have to, on the map, the robot will show me the map, and I say, this is the kitchen, this is my room, this is the living room, and then I tell the robot, go to the kitchen, and then he knows, it will transfer this word kitchen in X, Y position, and then we'll go there. This navigation based on laser is useful, works correctly, but when we made some trials in hospital rooms with elderly people, we faced some problems. For instance, if obstacles are high enough, and in hospital rooms, often it's a case because they make all the objects a little bit higher to make the cleaning easier. So the laser cannot see most of the object. And then the robot thinks, okay, it's free because my laser doesn't see anything, but anyway, at the higher level, the robot will collide. So in the bed, in the chairs, it's very difficult to avoid chairs. This dryer is very difficult to detect. Of course, you don't have this kind of dryer everywhere in the place, but okay, that's a kind of example. So of course, this kind of sensor, and you see the intelligence of the robot is limited by this perception. So you can have a very powerful AI in the robot. If you don't have the good sensors, your intelligence is useless. And I often compare to, there is an old story, an old movie called Miracle in Alabama, where it's a story of a young lady who was deaf, blind, and she was considered as stupid because, of course, if you don't have any input for your brain, you cannot think and you cannot react and you cannot act intelligently. So our robot is not completely blind, but with this limited sensor, cheap sensor, he has limitation. So that's why we have developed a new robot, experimental robot, on which we have implemented a powerful NVIDIA GPU. We have used another camera with a fish eye lens. And then, based on this, we have trained the robot to detect, to recognize, based on the 2D picture, what objects are transversable or not. So then we have the first solution we did, it's on each pixel we say, okay, on this image, this object, you cannot go through. And this object and this place, this pixel are free, you can go away. And then that way, we train the robot to recognize only on a 2D picture where he can go and where he couldn't go. Because it was quite difficult or long, we asked the robot to discover by itself if it's possible or not. And then that's what the video that was here, I will try. Okay, the robot will move. And then there is no more obstacle detection with the laser. He moves, and then he collides. And we say, okay, when you feel the bumper, then it means that that was not possible. And then the robot will learn by itself. And this, again, makes the difference between, you know, when you learn to play to Go, you know, it's easy to play games, millions of games during the night, but trying to discover the physical world only by training yourself, it's very, very, very long. And we broke a lot of robots during this kind of experiments. There are other experiments that are really painful for the robot, and we broke a lot. We've tried to teach now to stand up by itself. And it's, I don't dare to show this video because it's so sad to see the robot moving around, and we broke a lot. So this makes the difference between deep learning for only, I would say, virtual task and physical task. And after a while, after this learning, the robot is now able to navigate. Oh, sorry. Okay. Is able to navigate and to avoid any obstacles he will meet, even if there are some obstacles that he never learned before. We didn't, when this experiment was made during a fair in Munich, in München, and we did not retrain the robot in this environment. Based on what he learned in our office, he was able to avoid almost everything. You see, this kind of fence is very difficult to avoid only using 3D sensors, but here, with the with a 2D fish lens camera, it's easy. Of course, one limitation of this demo, because it's a social robot, what we would like is to have the robot avoiding objects, but going to people. So next step is for the robot to detect, to make the difference, and that's what we're doing today, make the difference between an obstacle that is an object and an obstacle that is someone. And if it's an obstacle, an object obstacle, then the robot should avoid it. If it's someone, a people, then the robot should go to and ask and discuss with the person. Then I will finish by a last, okay, of course, so you'll tell me, okay, avoiding obstacle is not that difficult. So so many efforts just to avoid people and to avoid obstacles. But it shows you that avoiding very simple tasks for human beings are sometimes quite difficult for a robot. And in the other way around, I will finish with a very complex gesture. In this demo, we have tried to teach the robot how to do this ball in the cup game. So first, we show it the good gesture. And then, based on kind of reinforcement learning, the robot will try again and again. Here, what you can see here, to evaluate the gesture, there is a camera on top of the robot and on the side for the robot to evaluate how far the ball falls from the cup. And after about 100 tests, the robot is able to succeed. And because it's a robot, if you don't change anything, then the gesture is perfect. It was not just luck. It was the robot converged on the perfect gesture. And it will win again and again. And of course, if you don't stop the ball, and if the ball is still swinging then the robot don't know, because it does not. It will try and it will fail. So we have to be exactly in the same situation. And when we succeeded, we put the robot in the office of the CEO, and we say, "I'll show you something very great." And then the robot tried and failed, because the ground was not exactly flat in the same way. So the good gesture for the first place was not a good gesture in the second place. Then the robot has to relearn again at its local place, and then succeeded again. So for that, all robots are okay. Based on this, we can develop plenty of application, but as a company, we cannot develop everything by ourselves. So we need partners. We need partners in research, academic partners. We need technology providers. People, for instance, we don't do speech recognition ourselves. We buy speech recognition to Nuance or any other providers. And we need application developers. We need partners. You have a list of them. Humanizing technology. Here is an Austrian partner who really has had plenty of success with all robots, and he developed the application that you can see downstairs. And because the robot is meant as a platform, it's quite easy, and you can, maybe Dimitros can testify, and with my colleagues downstairs. Today we have an SDK based on Android, so it's very simple if you are an Android developer to develop application based on using all the features that are provided by the robot, and then you develop your application on top of it. And to give you an idea of a complex architecture, we bring the robot with the SDK, and then you develop your application under Android, and of course you will use third-party service like speech recognition or IoT connection and so on. So you can gather all together plenty of services, and then you have a complete application that you can test with your final customers. And I'll finish with a video of one of our partners who explained this. And it's mainly focused on chatbots. When you meet a robot, you want to discuss. And the Microsoft, this morning, we had a very good presentation about this. People expect to interact in a natural language with the robots. Not only on very specific topics. If you are in a shops, then you will ask questions about the clothes. And then you can keep on chatting with the system, with the chatbot on your mobile phone. And what you like, when you arrive in the shop, you keep on discussing with the robot. And then you can ask many questions about a new question about the products that are available here. And once again, interacting with natural language is the most natural stuff you can do when you meet a robot. And then, okay, you can aggregate all intelligence that you can collect from other suppliers. And then you can ask many questions. Okay, what is the president of United States? What is the who defeated the PSG last time, and so on. Very interesting question, because you have access to knowledge base. So this Spark system has been developed by one of our partners in France, Intuitive Robotics, and it provides a solution to a final customer. You can be the next Intuitive Robotics in your country. We need plenty of partners. You know, the secret of the smartphone today is you can have thousands of applications on your smartphones. The application you need for your specific need can be developed. You will find it on the Google Play or Apple store. Today, we need plenty of people developing applications for robots. Being based on Android, we hope that we can open this community to more and more developers, and there is room for plenty of people. That's it. Thank you very much for your attention.
Now, perfect. Fascinating, fascinating. So now we will take 3 questions from the Slido questions. Let's see, the one that has the highest is, SoftBank owns Boston Dynamics. Why are you not using their technology?
Boston Dynamics is a very high performance robots for mainly on locomotion. Their skill is mainly locomotion. So it's the same way if you would say, why don't you put a Formula One motor in your little car? The technology are so different that today it's not really possible. You know, to give you just an example, the price of the inertial sensor of Atlas, the big robot, costs twice the price of a pepper. So really, we're not doing the same object. It looks like, but they are very different today.
I think that's a really good analogy to explain that. Thank you. Okay, another question. To what extent do you agree? What would you add to the 3 laws of robotics?
Okay, there are people working on this, but it's a same question. I think it has been mentioned before during the discussion about AI. It's very difficult for a robot to understand what is good and what is bad. First, it's difficult. Second, maybe what I think as a robot manufacturer is good or bad is not what you think. If I put my rules in your robot, do you trust me enough? Do you know what I think? Really? So whom ethics would I implement in my robot? So, and technically today it's very difficult. Nobody can do that. So of course, what we can do, it's very difficult to have ethical rules implemented in the low level of a robot. And what we can do today is to have very simple stuff like try to avoid to be hacked, try to avoid to have a too strong gesture to hurt people with very uncontrolled gesture and unlimited speed. So this is a way we can avoid harming people. Then, from the ethical point of view, is it good or bad to do this task or not? The responsibility will rely on the developers of the application.
Mm-hmm. Mm-hmm. Perfect. Okay. The next question. Okay. Will humanoid robots really be accepted by humans, or will they stay high-tech toys?
We'll see. We do hope. Okay. The first time we met elderly people. And to propose them to develop with us this robot to assist them, the first reaction was, are you crazy? We don't want robots. Robots are scary, robots are difficult to use, robots are dangerous. Okay, so they were very disappointed. We were very disappointed. And then we showed now the very little robot. And then they said, wow, he's so cute. What could he do for me? Maybe he can give answer the emails for me. Maybe he can call for me because I cannot use my smartphone and so on. So people imagine the way this robot can help. And really the test we made with elderly people, they really think that it's more than a toy. It's a presence, it's kind of someone for them that is with them, that can help them, and that can discuss with them. So for them, it's not a toy. When we can do the features that they expect, they won't consider it as a toy. Of course, as I said, for you, healthy people, this will probably stay a toy for long. Before you can ask, oh, maybe it would be another poll that we could have done. What are you expecting from a humanoid robot at home? And okay, probably for, okay, and probably what you would have asked, I'm completely unable to do it for a long time. So you're right. For maybe the next 10 years, for you guys, healthy, young people, this robot will stay as a toy. But for children, for elderly people, we really think that it could be a useful device.
Perfect. So unfortunately, we've run out of time, although we have very interesting questions. Please, if you're still very interested in that question, please come up to the speaker and ask, because he will be around here. Thank you very much. We will now make a break, and we'll resume at 4:45. Thank you.
Thank you.